In this video, we're going to learn about triangle inequalities. It sounds like inequalities, some of us struggle with it, but if you organize the information neatly, you will find it actually is really easy. So let's look at this theorem. It says that if one side of a triangle is longer than another side, then the angle opposite of the longer side is larger than the angle opposite of the shorter side. So it's much easier to look at this graph on the right. Look at BC is 5 and AB is 3. And the corresponding angle to segment BC is angle A. So that angle A has to be larger than angle C, which is corresponding angle to the line AB. Okay, so remember the segment, one side of the triangle and the angle opposite of it always correspond to each other. And theorem 411 says if one angle of a triangle is larger than another angle, then the side opposite is longer than the side opposite of the smaller angle. Obviously, it's just that we're reversing the previous theorem. So now we have an angle D at 60 degrees, angle E at 40 degrees, and then this line, which is EF, has to be greater than longer than DF, which is the blue line. And just a visual inspection tells us, yes, that is the case. So let's see how we use it in helping us solving problems. Here's an example. It says, name the angles from the largest to the smallest. And TV and TU. TV obviously is at 10. TU is at 8, so that's greater. And because of that, the angle U measure is greater than the measure of angle V, right? Because they are opposite. U is opposite of TV, and angle V is opposite of TU. So it's very consistent. Now, next, TU obviously at 8 is greater than UV, which is 4. And therefore angle V has to be greater than angle T. So the order of the angles from the largest to the smallest is, the largest would be angle U, which is an obtuse angle, and angle V and angle T. That's a T. That looks like a 7 there. There we go. Next example. Name the sides from the longest to the shortest. So now the angles are given, and obviously the opposite side of the largest angle would be the largest side, right? So in this case, because angle E at 86 is greater than angle D, we know DF has to be greater than FE. And angle D at 57 is greater than angle F at 37. So FE, the opposite of angle D right here, has to be greater than DE. So if we can rank them from the longest to the shortest, it would be DF, segment DF, FE, and DE. That's from the largest to the shortest. Another theorem, triangle inequality. The sum of the length of any two sides of a triangle is greater than the sum of the length of any two sides of a triangle is greater than the length of two sides. So in this example right here, you add any two sides together. CA plus AB has to be greater than the third side. AB plus BC has to be greater than the third side. BC plus CA has to be greater than the third side. Doesn't matter what kind of triangle it is, that's always true. So let's look at the example here. Can the side length form a triangle? Explain. So I have 3, 5, 9. It looks like the answer is no. But why? How can we prove that? So if we add this side and this side, if it's a triangle, it has to be greater than 9. But obviously 3 plus 5 is less than 9 because it's 8. So this is not a triangle, right? So second one, 3, 5, 8. So if I put it all together, notice that, again, 3 plus 5 equals to 8. You still don't have a triangle. It has to be greater than the third side. So the third one, 3, 5, 7, and you have to try out all 3 possibilities. 3 plus 5 is 8, which is greater than 7. 3 plus 7 obviously is greater than 5. 5 plus 7 obviously is greater than 3. So now we do have a triangle. Okay, so when we asked you, when the length of 3 sides are given in a triangle, you use the triangle inequality to prove whether you can form a triangle or not. Okay, guys, see you soon. Bye-bye.